From the very start of this course, we've been using objects and object-oriented terminology. We've been using predefined classes like scanner or random or APImage or file. We've been using these classes to solve problems, and we've talked about declaring variables of different classes. We've talked about assigning objects to those variables and then sending them messages or calling methods. In this unit, we're going to talk about the internal workings of classes, what's going on under the hood. We'll talk about the basic structure of class definitions, and you'll be able to read and modify classes and write new classes, all of your own. We'll just discuss the basics for right now, and we'll get into some more advanced topics a little bit later in the course. Now, maybe it would be helpful to remind ourselves what an object actually is. And it's a runtime entity that has data and can respond to messages or method calls. We think of that again as data, or the characteristics of an object, the attributes of an object, and behavior, the things an object can do. In this case, each particular instance of the Iron Man suit here is an object. Likewise, we think of a class as some kind of software package, or maybe a template that describes the characteristics of similar objects. So here, the way you might visualize it is the blueprint for an Iron Man suit. So in it, we specify what data and behaviors, what instance variables and methods a particular type of object will have. The fact that we're taking data and behaviors, or instance variables and methods, the fact that we're taking those and combining them into one single thing, we call this idea encapsulation. We're putting our data and behaviors into one entity. It's sort of an important CS idea to understand. It's nice because it lets us take particular information that we'll want to use and bundle it together with the things we'll want to do with or do to that data. I sometimes like to visualize it as this little diagram here, which is we have our data and we sort of wrap our methods around it, and we try to regulate our access to that data using methods. And finally, just a terminology reminder, we say that we instantiate objects. That's when we're actually creating an instance of a class. We're like taking that template, the class definition, and we're saying, make me a particular instance of this class. You might imagine Tony Stark creating an instance of the Iron Man suit based on his blueprints. It's worth starting with a very high-level discussion of how the Java virtual machine handles things when it comes to classes and objects. When you run a Java program, the computer memory has to hold three basic things. It has to hold all the class templates in their compiled form. It's got to hold the variables that refer to those objects, and it's got to hold any objects that we've created, as needed. Now, class templates are held in memory the entire time. So that is when you take your classes that you write and you compile them and they turn into .class files, into Java bytecode, those are always held there, and that's where each method's bytecode lives as part of its class template. In contrast, memory for data or for instance variables, that's allocated within a particular object when you make it. So even though all class templates are always in memory, which means that the bytecode for methods is always in memory, the bytecodes for behaviors is always in memory, individual objects and their information and their data, their instance variables, individual objects come and go. An individual object will first appear and take up some space in memory whenever we first instantiate it, as we do here with this new APImage object. That's what that new keyword does. Then, as soon as it's no longer needed, it's going to disappear. The JVM keeps track of whether we're actually still using an object based on whether or not there are any variables still pointing to it. If we have an object where we don't have any references to it, there are no variables pointing to it, we can't actually use it. It's not possible for us to call any methods. So Java is going to assume that it's okay to delete, and then it goes to garbage collection. That object will get taken out to the trash. You can see that that's happening here. I made this new APImage object called img, and then actually right after that, I set img, the variable that was referencing it, the variable that was pointing to that object, I set it to null. I could have set it to anything else too, but now there's nothing pointing to that new object. So the Java virtual machine will garbage collect it. Now, fortunately, the JVM does that for us automatically. In some other languages like C++, you have to do that memory management yourself. You have to delete an object specifically when you don't want to use it anymore. That can often be a hassle because maybe you delete an object too early and you still need it, or maybe you never delete any objects and you end up writing a really space-intensive program. But fortunately, you don't have to worry about that if you're writing in Java. Now, we've talked about these before, but it's worth reiterating these three important characteristics of objects. First of all, objects have behavior, and those are defined as the methods of the class, what an object can do. We also have a state in an object, which is just another way of saying that at any particular moment, an object's instance variables can have particular values. So that would be like the current values of all of the instance variables in an object. Typically, the state of a particular object changes over time. We send messages or we call methods from objects that do things, and one of the things we'll often want to do is change the values of those instance variables. For instance, assigning a test score to a student object. So it's unlikely that your object's state will remain exactly the same over the course of your entire program. An object also has its own identity, which is to say that it's distinguished from all of the other objects that are in the computer's memory during that program's run. Even if two objects have the same state, which is to say, even if all of their instance variables are exactly the same, they're still distinct objects in terms of identity. They still occupy separate space in memory. Identity for an object is handled sort of behind the scenes for us by the JVM, but you don't want to confuse that with its state or with variables that are referring to the object. You can have more than one variable referring to the same object, like you see here in this picture. So we have 3 Iron Man suit objects, 2 of which have identical state, right? This one and this one have exactly the same attributes, but we have different variables pointing to them. Suit 1 points to this object, suit 2 and suit 3 both point to this object, and we can have another instance of the Iron Man class with different state, and that's referenced by suit 4. So again, we don't want to confuse identity, variables that point to objects, or the state of the object. Okay, last little topic for today, we want to talk about clients and servers and interfaces. When we call a method, there are really 2 objects involved. And again, we can think of calling a method as sending a message. So we might think of the object that is calling the method, and we might think of them as the sender of the message or the client. And we might think of the object that is running a method as the receiver of the message or the server. We'll use this terminology throughout to describe the 2 objects involved in any method call. The client sends the message and is calling the method. The server actually receives the message and runs the method. As you might predict, if you're a client and you want to call a method from a server object, well, then you gotta know how to call it. And that's when the interface of a particular method comes into play. You need to know what kinds of inputs it takes and what order to pass them in, what name the method has, and what kind of output it's going to give you. To summarize, a client or a method calling object needs to know about the method it's trying to call in order to call that method from the server. But it doesn't actually need to know how that method runs. All it needs to know is what information to give in order to call the method. It doesn't actually need to know what's happening under the hood. We call this idea information hiding. We don't need to know how a method is implemented. Only the person who writes that class needs to know it. All we need to know is what's expected of us when we call a method and what we should expect as a return value or as an output. In fact, this is really helpful because I could change everything about the way a method does what it does, but as long as I don't change the way we interact with it, which is what inputs we pass and what order the inputs are in and what the name of the method is, as long as we don't change those things, client objects can still use that method, even though it's working completely differently under the hood. You might think of this as an engine, right? If I take an old engine, when you run your car, you don't actually see the engine and think about how it's going. You just know, okay, I need to turn the ignition, I need to hit the gas pedal, I need to turn the wheel, right? You know how you need to interact with it, but if you upgraded the engine, you might not actually really even need to know the details of how that engine has been upgraded. You just experience the benefits of getting better performance with you doing the same things, turning your key, hitting the gas, turning the wheel. That's a great benefit of information hiding. Talked about a lot of stuff today. A lot of it was at a sort of conceptual level. We'll dive into some code next time. But if you can explain the difference between a class and an object, if you can tell me at a very high level what happens to an object's memory storage when there's no variable pointing to that object anymore, you can tell me what are the 3 important characteristics of an object that we talked about, and talk about the client-server relationship, what that means in terms of objects calling methods, and finally, what the interface of a class is. If you can talk about those things, then you should be in pretty good shape as far as understanding what's in this lecture.